All right, let's just jump right in. For over 100 years, we've lit up our nights pretty much one way, with a wire and a bulb. Simple, right? But what if we could scrap all of that for something alive? Today, we're going to explore a completely radical new way to light up our world.
I know. It sounds like something straight out of a sci-fi movie, doesn't it? Imagine a park or a street lit up not by a power grid, but by the soft, gentle glow of nature itself. It's a huge question for sure, but the answer might be a lot closer than you think.
And this is why that question is so important. 40%. In some cities, that's how much of the entire electricity budget gets eaten up by streetlights. That is a staggering amount of money and energy. It's this huge problem that's literally hiding in plain sight, right above our heads every single night.
So first, let's talk about the real cost of our electric night. I mean, conquering the darkness has been a human goal forever. But it turns out it comes with some serious and often totally invisible side effects.
And the scale we're talking about is just massive. Globally, we are burning through 159 terawatt-hours of electricity every year just on streetlights. All that light creates sky glow, that orange haze over cities that just erases the stars. But this isn't just about a pretty view. This artificial light completely messes with bird migration, it confuses insects, and it can even disrupt our own sleep cycles. So the bottom line is, our solution to darkness has ended up creating a whole new set of problems.
But what if there's a better way? I mean, nature has been making light for millions of years, and it does it with an efficiency that's just incredible. So let's dig into the secret of what scientists call cold light.
The magic word here is bioluminescence. You've seen this. Think fireflies or those amazing creatures deep in the ocean. It's simply light made by a living thing. And the key difference is that it's a chemical reaction, not a heat-based one like a light bulb. It creates light without wasting tons of energy getting hot.
So how's it work? Well, it's actually a surprisingly simple recipe with just 3 key ingredients. You have luciferin, that's the molecule that actually makes the light. Then you need luciferase, which is an enzyme that acts like a spark to get the whole reaction started. And finally, you need oxygen, which is the fuel. You put those 3 together, and you get light. Simple as that.
And here's where it gets really cool. Let's put them head to head. A regular old light bulb works by heating a tiny wire until it glows white hot. Almost all of the energy you pump into it is just wasted as heat. Bioluminescence, though, is all chemistry. It's so efficient that less than 20% of the energy is lost as heat. It is basically nature's perfect light bulb.
Okay, the science is awesome, but how do we take this out of a firefly and put it on a city street? Right now, scientists are really going down 2 main paths. One is genetically engineering trees to make their own light, and the other is harnessing algae in special tubes to create living lamps.
And these 2 approaches have some really fascinating trade-offs. On one side, you've got glowing trees. Scientists pop in some genes from glowing mushrooms, which lets the tree create light using stuff it already makes. The huge benefit? The streetlight literally builds itself out of sun and soil. The challenge? It takes a while, and you have to be super careful about those glowing genes getting out into the wild. On the other side, you've got the algae in tubes. These little guys glow when you agitate them. The big win here is no genetic modification of the environment, and, as a bonus, the algae eats CO2. The challenge? Well, it's basically a living pet. It needs food and CO2 to stay alive.
And that Avatar-style dream of a glowing forest? It actually took a massive leap forward in 2020. That's when researchers figured out how to use genes from bioluminescent mushrooms. Now, this was a total game changer because mushrooms use a compound to glow that all plants already have. This means the plant can produce its own fuel and glow continuously all by itself.
And hey, this isn't just a theory in a lab. The algae approach is already out there. There's a company in France called Glowy, and they're already installing what they call liquid streetlights. They're these tubes filled with glowing bacteria that light up public spaces while absorbing CO2. It's a streetlight that literally breathes.
So with the science pretty much sorted out and some early versions already working, the next big question is, what does the journey look like from a cool lab experiment to a regular old lamppost on your street?
Well, the progress has been moving surprisingly fast. If you go back to 1986, scientists made the first glowing plant, but you had to kind of feed it the glowing chemical. Then, fast forward to that huge mushroom gene breakthrough in 2020, and bam, plants could suddenly power themselves. And now, today, you can actually go online and buy a commercially available glowing plant, the firefly petunia. We've gone from a lab theory to a product you can buy in just a few years. That's fast.
But okay, let's be real for a second. There are still some major hurdles. First, brightness. Right now, the plants are more like mood lighting, They're not bright enough for a major highway.
Second, what about seasons? If you have a glowing oak tree, what happens in winter when it loses all its leaves? A streetlight can't just go dark in November. And finally, the really big one. How do you make absolutely sure these genetically modified genes don't escape and create some kind of glowing invasive species?
But despite all those challenges, the potential here is just so much bigger than an electricity bill. This is about completely reimagining what a city even is. It's about building a city that actually breathes. I absolutely love this quote. The bioluminescent streetlight suggests a city that is a garden. It just perfectly captures the shift in thinking. We stop looking at our cities as machines built to consume things and start seeing them as living, growing ecosystems.
And this vision has real, tangible benefits. The light itself is this softer, bluish-green color that dramatically reduces sky glow, so we might actually be able to see the stars again. The infrastructure builds itself from sun and soil. No more mining for copper wire and steel poles. And like we saw, the algae-based lights are actively cleaning the air. It's just a profound way to reconnect our man-made world with the natural one.
So, where is all this headed? Well, within the next 5 years or so, expect to see these algae lights showing up in parks and pedestrian zones. By the 2030s, we could start seeing shrubs with engineered glowing bark to light up pathways. And by 2040, we might just be walking down the very first city streets lit entirely by the living glow of the trees above us.
And that really brings us to the final thought here. For hundreds of years, our cities have been designed like complex machines. This technology offers a totally different path. So I'll just leave you with this question. What happens to us and to our world when the machines we live inside finally come alive?